What did you get, Charlie Brown?
I got a rock. I got a rock. Rock. I got a rock. 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 I got a rock. I got a rock. I got a rock. Rock.
What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock.
What did you What did you get, Charlie Brown?
I got a rock. I got a rock. 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 I got a rock. I got a rock. Got a rock. Got a rock. 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 I got a rock. I got a rock. 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 I got a rock. I got a rock.
All right, so today we're going to continue on strings and the string processing. You'll have your string labs tomorrow, and then of course your string hack on Thursday. Your reading on strings is due at midnight tonight, as usual. Now we're back in the regular schedule after the fall break. We previewed the string length function last time when we did a deep copy, right? Remember that the string length function is you use the strlen function, right? And you give it the string that you want the length of. It returns the number of characters in the string, not including the null terminating character. So you can imagine what it looks like, right? If I were to actually open up this function, all it would do is start at the string and make a counter. One character, two character, three character, dot, 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 until it got to the end of the string and saw that null terminating character, at which point it would return the number of characters that it had counted up until that point. Right? So to remind us of what we were doing on Friday, we wanted a deep copy of a string. And to do that, we use the string length function. When we've got my name here and we want to make a complete deep copy because we want to change it and we don't want to make changes to the original, we need to dynamically allocate memory for it. And to do that, we need to count up the number of characters in it and then always add one. The reason we always need to add one for strings is because we need to handle that null terminating character, right? And then we use the strcpy function to copy whatever we were trying to do into that other string. Strcpy was short for string copy. Now I challenged you and I asked you to think about what it would look like if you put this into a function over the weekend. Let's go ahead and do that now together. Right? What would that look like? Right? Well, first of all, what's my return type going to be? If I'm going to take a string and make a completely different deep copy of that string and give that string back to you, I'm going to return a string from this function. Right? Now, do we have the keyword string in C? No. In other programming languages, you might, right? But not in C. In C, a string is a what? Is it a single character? Nope. It's an entire array of characters, a string pointer, str star. Right? Now, what should I call this function? Call it what it is. Deep string copy, right? Or copy deep string or something like that, whatever you want, right? Now, I'm going to take a string as an argument, char star s, right? And I'm going to make a copy of that string, okay? Now, first of all, is there a way to improve on this? Am I going to be making changes to your original data? Hopefully not. That's the whole point of making a deep copy. Remember, a shallow copy is when you've got two references to the same thing, so that changes to one affect the other because you're referring to the same thing. I want two completely different copies, a deep copy, so that changes to one are not affected by the other, or don't affect the other. So how can I advertise the fact that I will not be changing your string? Const in front of it. Right? Now, let's take the code that we were working on last time and adapt it. Right? Now, we're not copying name. Instead, we're copying this string, s. Right? So what is the length of s plus 1 for that null terminating character times however many bytes a character takes. Granted, that's probably going to be 1. That's a bad style. Right? Let's go ahead and keep it like this, size of char. Right? And this is my copy instead of the full name. And then I will copy into the copy the original string s. Then I'm done. So I dynamically allocated memory for the new string. I copied the old string into the new string. What's GCC going to have to say about it the way that I have it right now? With the wall flag, demo.c. What is it warning? Control reaches the end of a non-void function. We're still seeing this as common in the grader, right? That people are not reading all the output. They're not using the wall flag locally, so they never see this. And then they're not reading all the output of the grader to see that we are using the wall flag at all times, right? So what was my mistake here? Am I returning anything? Nope. So should I be returning s? That's what you gave me, right? You have it. Why do you need it back, right? Should I be returning 0? The wall flag goes away. Oops, sorry. Save. Oh, you know what? It's down here. Let me go ahead and get rid of this, first of all. And then there. The wall flag is no longer warning me about this return value right here. Because it thinks, well, you're returning 0. You must know what you're doing. Go ahead. I'm not going to warn you about that. Should I be returning 0? Is 0 a memory address that sounds like it's valid? No. What should I be returning? The copy, right? You gave me a string. I create a new string and give it back to you. That's the copy. Right? Char star is the return type. Copy, what's its type? Char star. Right? They match. Now, how do I use it down here? Well, I want to make a copy of, let's go ahead and get rid of all this, and call deep string copy of my name. Right? Do a deep copy instead. Right? Now I don't need to take care of any of that stuff. There we go. And GCC. And we see that I'm having a deep copy now. And now again, if I make changes to 1, say the original, I make changes and say name of 0 is equal to a lowercase c instead. Right? Then that will not change full name because it is a deep copy. Right? Lowercase c, uppercase c. If it were a shallow copy, one change to 1 would affect the other. Right? As you're processing data and you change that data, you may not want the original to change because what if you need to process it again for whatever reason, right? You want to make a shallow copy. And now that we've got this function, right, we can use it over and over and over and over again. Okay. All right. So I'll make sure that you have this in the notes at least. But I think that we provide it in several labs or other code samples, right? You can write a deep string copy function. See, there we go. All right. What's next? Where's the C type? All right, so here's some other convenience functions that you may want to, or that you should be at least aware of, even if you don't use them, but you probably are going to have cause to use them later. There's another library that is similar to the string library that operates on single characters. The ctype.h library has many functions that operate on single characters. It's not the C as in the C programming language type, it's C as in character type. For example, you can determine whether or not a character is an alphanumeric character. Is alpha of C, alpha, there we go, returns true if C, the character C, is an alphanumeric character. Alphanumeric characters include 0 through 9, A through Z, lowercase, and A through Z, uppercase. It'll return true if it's any one of those. If it's punctuation, for example, it'll return false. But guess what? There's is it punk? Let's look it up because I don't have it here. C-type library. Right. All you have to do is RTM, read the documentation, find out what's available here. Punctuation. Yep, it's is punct, right? There. So is punct will return true. Returns true if C is a punctuation character. Punctuation character would be period, exclamation point, question mark. What else? I don't know. What is the complete list of punctuation? Looks like, I don't know. At least those three I would be sure of. And apparently slash is also a punctuation character. I don't agree with that, but whatever. Space is not a punctuation character, but that's okay because you have another function called isSpace that's going to return true for all white space characters. The space, the tab, the endline character, etc. Right? You have is lower and is upper to determine if it's a lowercase or uppercase character, letter character. Now that'll return false if it's like a digit or something like that. And then you can also, of course, have conversion characters or conversion functions. If you have a lowercase character or an uppercase character, then you can convert it to its uppercase form. Right? And is digit and a bunch of others, right? So before we go on, let's do an exercise. Let's write a function. Exercise. Write a function to convert a string to all uppercase characters. Right? Pretty easy. Let's go ahead and come over here and do that. Well, first of all, what should I call this function? Could I call it toUpper? No, why? Where's toUpper? toUpper, right? In the C-type library, we already have a toUpper, right? So what should I call mine? To uppercase string, maybe? Okay. Am I going to be returning anything? Probably not. If you give me a string, I'm going to change that string for you. We'll look at a different version here later on. Right? To uppercase string. And I'll take a string. Const char star s. I'm going to convert that string to uppercase. Now, the way that I wrote it is like the other function. I put a const in front of it. That means that I'm not going to be able to make changes to that string. Is that what we want? Nope. I want to make changes to it because I'm going to convert it to an uppercase string, right? For example, I'm going to convert, say, Christopher. Well, here, I'll stop using my name here. Let's go ahead and go with computer. Computer. I will, computer with an exclamation point here. I'm going to want to convert that to computer, exclamation point. Note here that the uppercase C is left unchanged. All the other lowercase letters have been converted to an uppercase letter. And the punctuation character there has been left unchanged as well. Okay? So I want to convert that string to all uppercase letters. Ideas. I'm going to want to iterate over each character, right? And if that character is if it's a lowercase letter, I want to convert it to an uppercase letter. So how do I iterate over all the characters? I did it once before when we were demonstrating stuff. Do we remember how? Idiomatic for loop. For int I equals 0, I is less than n, where n is the number of characters in it. I don't know how to do that. I++. You guys know how to do that, though. How do I get that n? What are the number of characters in that string? strlen of s. Right? Now, there are other ways of writing this. You could write it as a for loop or a while loop instead. While the current character is not equal to a null terminating character and just keep going or something. But I'm going to go ahead and do it like this for simplicity. Right? There are better ways of doing it, but this is the most straightforward. Right? So if the character of I is uppercase or is lowercase, convert it to uppercase. ... Question online. Is alpha only return true if it was a letter, not a number? I don't know. Let's check it out. Find is alpha. Pass oh, that's true. If it's alphabetic, not alphanumeric. And as they point out on the chat, is alnum is what you want if it's an alphanumeric character. So in other words, 0 through 9, A through Z, and A through Z. So let me go ahead and correct the notes on that. Thank you. Random internet person. All right, there we go. Nope, you are right. You corrected me. Thank you. All right, so back to our exercise here. How do I determine if something is lowercase? If is lower of s sub I. Right? Then I will convert it to an uppercase. How do I set one particular character in a string? Well, like you set anything in an array. I'll set it equal to the uppercase version of it. So 2 upper of s sub I. Now, do I really need that if statement, though? Let's optimize it. By the way, let's just go ahead and return, and we're done. Right? We're not returning anything. Do I really need this if statement right here? Right? Let's take a look at the documentation for 2 upper, or tupper. Following declaration is 2 upper function. The function returns the uppercase equivalent to C if such a value exists. Else C remains unchanged. That means that after reading the documentation here, I don't need this if condition. If it's already an uppercase C in computer, it'll stay the same. If it's a non-letter value, like the exclamation point at the end, it'll stay the same. Right? So I don't even need that. Right? And I can go ahead and use this. Right? Much simpler code. I was able to get it down to, or eliminate 2 or 3 lines of code. Okay. Let's test it, make sure that it works. I'll go ahead and use that name still. Well, here, I'll keep all that stuff there. Instead of changing just the first letter here, let's go ahead and go with, what did I call it? 2 uppercase string. Right? And full name. Actually, the original name. I'll go ahead and change the original and then keep the full name in my, oops. Oh, there. What did I forget to do? I pointed it out. Const was wrong. Why? I'm not able to make changes to it, but I never eliminated it. There we go. Now it should, oh, and then finally, what do I need to include now that I'm using it? Include the C-type library. There we go. And there, my entire name is now all uppercase. Okay. Well, okay, that works if you create a deep copy and then change the original. What I want to do, though, is I want to combine that into one function. Instead of 2 uppercase string, I want a copy of get uppercase copy of the string. And here I will put in const char star because I do not want to change the original. You give me a string, I'm going to make a copy of it, And then I'm going to change a copy of it, including all the uppercase letters, right? And then I'll give that back a new copy, all in one shot. What's my return type going to be here? Char star, good. Get uppercase copy. Now, should I go ahead and copy, paste, right? Copy, paste, right? Anytime you find yourself copy pasting like this, right? That should be a huge red flag. Maybe I'm doing something wrong, right? Your last hack was designed so that you could have one function call another function. For example, the reversal. There was you had an array, and then you reversed it, and then you had a reverse copy. One of those should have only been one line, right? Or one or two lines, where you create a copy, and then you pass it to another function, and it reverses it for you, returning that, right? Or vice versa, right? Some people did it backwards, and that's fine, but it would have been better to do it the other way. For example, here, what I'm going to do is I'm going to create a string copy, right? Copy is equal to deep string copy of S. And then I'm just simply going to reverse that, or not reverse it, but I'm going to convert it to uppercase and then return the copy. There we go. All in one shot. The whole reason that you write functions is so that you can use them and reuse them, so you're not copy pasting large chunks of code. In this case, 2-3 lines of code, but same thing, right? So get uppercase copy here. Char foo is equal to uppercase copy of name, and then I'll print out foo and the original name as well. All in one shot. Oops. Oops. What? Okay. Since this is a demonstration, the order matters because I'm not using proper prototypes. So I'm going to have to put this up here because I use it down here. Right? And before it was down here, and I used it up here. The order matters. This is why we use prototypes to begin with, so that the order doesn't matter. One of the reasons. Right? There we go. Foo is all uppercase. It's a completely different copy. The name and the full name are still preserved. Right? So, nice little exercise right there. Utilizing the C-type library. And again, it's for character types. It's not for, the C language types. Right? Okay. What else do I want? Where is string comparisons? There we go. String comparisons. Right. So you will often need to compare the contents of one string to another. ... Can you use the equals equals operator? Let's find out. So I'm going to go ahead and get rid of all this stuff here since it's already in the notes. And get rid of all of this stuff and start over with some new strings here. So char star or A is equal to apple, and char B is equal to oranges. Orange. There we go. So I'm going to compare apples and oranges here. Right? So if A is equal to B, then I'll go ahead and print out that they are the same. %s is equal to %s end line. Right? A and B. Now, would you expect that to be printed out in this case? Are apples and oranges the same thing? No. So let's go ahead and print out an alternative. %s is not equal to %s end the line, A and B. Right? And as you expected, apple is not equal to orange. Right? But if you compare apples to apples, or apple to apple, what would you expect now? Apple is the same thing as apple, right? But same thing, it's not equal to apple. Why? What is A? What type is A? It's a string. A is a string. Right. Now, replace string with what we use in C. What is a string in C? A char star, right? A pointer. A memory address. This is a pointer. A memory address. Right? Is that memory address the same thing as that memory address? Right? Well, let's take this over to Python Tutor and ask whether or not those two things are the same thing stored in memory. Right? Visualize this execution. And, come on. reasonably fast. You tell me. Are those the same things stored in memory? Nope, I have two completely different copies here. So when I go to actually compare them, and I'm comparing them as a memory address, it says that they're not equal, right? Equals equals compares memory addresses, not the contents of the string. So for example, if I change this so that B was actually referring to A, right? B is equal to A, that's a shallow copy. Right? First of all, it's a kind of a sort of a memory leak, but hopefully I'm allowed to do this. Come on. I can't do that. Fine. Make you go away for a second. Char star B. There we go. Now, this is going to print out that they are equal. Why? Because they're pointing to the exact same memory address. Let's visualize this to show you what I'm talking about. Edit this. So now we don't have two apples. Instead, we have char star B, and I'm making it point to A. Right. When I walk through this, you'll see that there's only one copy of apple, and B refers back to it. So of course the memory addresses are going to be the same, because they are. Right? So how do we take care of this? Right? I really do want to compare the contents of the string. In other words, I want to say that that apple and that apple, they have APPLE, they're equal. Right? What I need to do is I need to bring in the library function to do it. Right? Int result is equal to strcmp, A and B. I'm going to take A and B and I'm going to compare them. strcmp, CMP is short for compare. str is short for string. String compare, right? Now that's going to return an integer value, result. It's going to return something negative. We'll go over this in a second more formally here in a moment. But if the result is less than 0, that means that A is less than B. Right? A comes before B. Printf, %s comes before %b or s and the line A and B. Right? Otherwise, if the result is 0, then that means that they're equal. Printf, %s is equal to %s and the line A and B. Right? What's the only other possibility here? B comes before A, and that would be the result is it's either negative, 0, or positive, right? Now, strictly speaking, I don't need that if condition because it's one. If you've eliminated the first two possibilities, the third one is not there. But I'm doing this for demonstration purposes. Printf %s comes after %s and the line A and B. Right? So, apple and apple, they are equal. They're not equal as far as their memory addresses are concerned, but they're equal as far as their contents are concerned. Now let's change this back to apples and oranges. Or orange. There we go. Okay. So which one of those would come first, intuitively? Apple or orange? Apple. Why? Because of the dictionary, right? A comes before O. Right? But what if I do something like this? Capital O. And let's go ahead and compile this and find out now what comes first. Orange. Apple comes after orange. Orange comes before apple. Why? Because, well, it's capitalized. Remember our ASCII text table? Right? What does it look like? All the capital letters come before all the lowercase letters. Right? So as a consequence, this is not dictionary order. In the dictionary, if you look up the dictionary, all the A's come before all the B's, regardless of capitalization or lowercase. That's not the case when you're talking about coding. So therefore, we don't call this dictionary order. We don't call this alphabetic order. We call this lexicographic order. Right? So this is the strcmp compares two strings in lexicographic order. Right? That is the ASCII table. Right? Questions so far? Then based on that knowledge, let's go ahead and change this to uppercase A, apple, and orange. Which one's going to come first now? Now it's back to apple. Apple comes before orange. Right. Let's go back to apple and apple. Z. Which one comes first now? The singular form or the plural form? Now this does make sense with respect to the dictionary. Which one would come first? Usually plurals aren't in the dictionary, are they? Right, there. Apple comes before apples. They're not equal. Okay? All right. If you want to compare based on case insensitive comparisons, ... you use strCMP, or case CMP, A and B. There we go. So let me copy this entire thing here and do another one. Ignoring case. There we go. Ignoring case, ignoring case. Okay? This one, it doesn't matter if it's uppercase, lowercase. This is still going to be lexicographic order, but it's going to end up ignoring the case, lowercase or uppercase, giving you alphabetical order, like the dictionary order. Okay? So let's come back up here and change this back to apple and orange. Right? Where we've got uppercase on both of those. Right? Actually, no, sorry. Let's go with apple and orange. Now, normally orange, big O, orange, would come first because of the ASCII text table. But on this second comparison where I ignore the case, apple now comes before orange when you ignore the case. All right? As far as uppercase, lowercase go, it's pretty clear on how things work. But what about punctuation? If I had, I don't know, if I had apple and apple, but I replaced A with an exclamation point, which one comes first? Yeah, I don't know. We'd have to look at it up in the table, right? Probably the exclamation point. There we go. Exclamation point comes before apple. Why is that? Where's the exclamation point in the ASCII text table? That's a good question. Does anybody see it? There, 33, thank you. Right, almost at the beginning. Right? That's why space comes first. And guess what comes before anything else ever? The null terminating character. This is why apple came before apples. APPLE, they matched up to those first 5 characters. What was the 6th character? S and the null terminating character. Which one comes first always? The null terminating character. So, there's rhyme and reason to this table. They didn't just design it willy-nilly. In fact, there's a whole bunch of other little tricks to this table. If you want to convert from an uppercase to a lowercase or vice versa, you just need to flip one of the 8 bits, right? And it gets the job done with minimal effort. Right? There are a whole bunch of things like that that you can, the little tricks that this table was designed with. All right. Let's see. You can also do comparisons with a byte limited version. So, for example, strncmp. We talked about byte limited versions before, didn't we? Maybe, maybe not. Nope. Okay, so we'll talk about it here. We'll talk about it with the other two in a second here. But otherwise, let's go ahead and use it with byte limited versions with the comparison here, right? So strncmp, you provide a third argument, the number of characters to compare. Right? So, for example, result is equal to. Let me reset those values. A is equal. I can't redo that. Let's go with char D, C and D. Right, there we go. And let's see, apple pie. There we go. And char D is equal to just apple. Right. Now, are those the same strings? Definitely not. But what I can do is I can limit my comparisons to the first 5 characters. Right? So strncmp, I can limit it to just the first 5 characters. APPLE and APPLE those are going to be the same. So it's going to end up saying that they're equal, limited to 5 characters. The first 5 characters, by the way, too. Right. There we go, and there we go. And oh, do I need to? I need to change C and D to all this stuff. C and D. C and D. C and D. And C and D. Right. There we go. And when I run this, I see that apple pie is equal to apple when you're limiting it to the first 5 characters. What happens if I limit it to the first 6 characters? Right. Which one comes? Are they equal now? Careful. What's the 6th character? Space. What's the 6th character here? Null terminating character. So which one comes first? Null terminating character. And so apple will come before apple pie. Or apple pie, or apple pie comes after apple. Apple comes before apple pie. Right? Depends on your perspective, which one you're facing. Right? All right. So that's a byte limited version of all of those things. And you can play around with this. I'll make sure that you've got it in the notes. Right? So what we just did was what's called a comparator pattern. Right? String comparison functions like strcmp, strncmp, and strcasecmp. And there is also a strncasecmp, I think. Let's go ahead and look it up. Man, strncasecmp, or is it casencmp? Yeah, there we go. strncasecmp would do both of those. So it would limit the number of characters that you want to compare, and it would also ignore the case on it, right? So those string comparison functions all follow a comparator pattern. So don't bother looking it up in a dictionary what a comparator is, because it's a term of art, right? It's only in our discipline that we make up words like this. I don't think it's actually a dictionary word. A comparator pattern is a general, abstract comparison. It takes 2 arguments. Right? It's a function. It is a function that takes 2 arguments called A and B. And I'm going to go ahead and put them in math mode here because I don't want you to think of them as code. I want you to think of them more generally as things, right? It could be strings. It could be integers. It could be things that represent students. Here's student A and here's student B. What order do they go in? This student comes before this student. Why? Maybe their last name, first name comparison. Maybe their GPA, ascending, descending. Maybe their NUID, right? In ascending, descending, right? These are all abstract notions of how you compare things, right? It takes 2 arguments. It returns an integer, right? With the following pattern. It returns something negative if A comes before B, is strictly less than B. It returns 0 if they are equal, again, conceptually. Right? A equals B. And it returns something positive if A is greater than B. Equivalently, B comes before A. Right? There we go. Think of this in terms of the number line. X. You've got negatives over here, you've got 0 right here, and you've got positives over here. A and B lie somewhere on the number line. If they're in order, it returns something negative. Right? If they're out of order, it returns something positive. And if they're equal, they lie right in the middle of the number line at 0. Right? That's how you should think about it. You should think about it in terms of the difference between those things. Right? If I were treated them as numbers, 50 comes before 100. Well, what's 50 minus 100? It's something negative. Right? If I flip those around, 150, they're out of order. What's their difference? 100 minus 50 is going to be 50, something positive. If they're equal, 100 and 100, what's their difference? 0. Right? 100 minus 100, 0. Right? So something, I emphasize this, something negative. You cannot read anything into the value that you get back from this function, right? There is no guarantee. It could return -1. It could return -42. It could return -105, right? It doesn't matter. All you can trust is that it will be negative, right? And that's why in our code over here, we were checking for the result. Is it negative? Is it 0? Or is it positive? Right? One of those 3 outcomes will come from a comparator pattern. It's an abstract notion. Later on, we're going to use this when we search and sort things. We're going to write our own comparators with the same exact pattern. Here's an object. Here's another object. Are they in order, out of order, or are they equal? Right? Something negative, something positive, or 0, depending on the relative ordering. Okay? All right. So that's comparing strings. Let's talk about the byte-limited versions of the other two. Right? Byte-limited versions of functions, right? Sorry, go over here. There we go. So both strcmp, or CPY, excuse me, and strcat. Remind me, what were those again? strcpy is short for string copy. strcat was short for what? Say what? Concatenation, right? Find oops, not there. Find, oh, nope. Okay, I'm not going to be able to search. Where is it? String, did we not do, yeah, we did string concatenation. String concatenation means appending one string to the end of another. So if I've got string A and B, I've got A, I'm going to append B to the end of the other. Remember that it assumes that they're both valid strings and that the destination string is big enough to hold A and B and the null terminating character. So it's on you to make sure that you've got a string big enough for that, okay? But you have also byte-limited versions of it, right? Have byte-limited versions. Right? strncpy and strncat that take a third argument, n, the number of characters, the maximum, I should say, maximum number of, there we go, characters to copy or concatenate. Right? Again, same rules apply. Same rules apply that the source, destination are valid and the destination is big enough to hold both, plus the null terminating character. But there's a new rule, right? That if the null terminating character is seen by either function in the first n bytes, n characters I should say, it is automatically copied for you. Right? If not, it becomes your responsibility. Right? Misspelling everything today. Responsibility. There we go. Becomes, there we go, fixed. So let's take a look at an example here, because this is going to be very, very useful to do what are operations called substrings, okay? That we'll continue with probably on Wednesday. So let's go ahead and take a look at an example where I've got, say, char name, full name, right? And I'm just going to make this big enough, right? 100, right? So let's go ahead and copy into that. Let's go ahead and put my name in there, Chris. There we go. Now let's concatenate onto that my last name, or my let's see, strcat. No. How do I want to do this? Let's go with full name, Christopher Michael Burke. There we go. I just want my first name. So first name. And I'll just make this big enough to hold it, right? I want to copy, let's say, strcpy into my first name, my full name. And then let's go ahead and print it out. Now, this is not going to work, right? This is not when I'm going to get what I want. First name is equal to %s and the line first name. There we go. Now, this is going to end up copying my entire name, Christopher Michael Burke, right? And when I print this out, we'll see my full name there. I don't want to copy my full name. What I want to do is I want to copy the first 5 characters, just my Chris. That's it, CHRIS. To do that, I don't use str copy, CPY. I use str ncpy. And then I need to specify how many characters you want to copy over. How many did I want to copy over? 5. Okay. What that's going to do is copy over CHRIS, the first 5 characters. Now, did we see a null terminating character in the first 5 characters there? Nope. Consequently, strncpy will not put that null terminating character in there for you. We need to handle that ourselves. First name of something is equal to the null terminating character. Excuse me. Right, there we go. Where do I put that something? So CHRIS 0, 1, 2, 3, 4, 5. Right. And when I do that, I only get my first name. Excellent. Right. What about concatenating on my last name now? Right. Let's see. No. No. What do I want to these are all toy examples, so what do I want to concatenate? I don't know, just make another string foo. I don't know. Hello world. These are always the go-to. Hello world, foo, bar, etc. Right? So hello world. And let's go ahead and concatenate onto my first name. First name, str cat. Onto first name, the hello, foo, right? And let's print that out again. Now, the default behavior here of, hello world, sorry, there we go. When I run this, the entire message, hello world, will be concatenated onto the end of my first name. That's not what I want. Let's just go ahead and concatenate hello onto the end of my first name. So Chris hello, right, is what I want. So we use a byte limited version of this. And once again, I will limit it to 5 bytes. So it'll copy over HELLO. Again, did you see the null terminating character in those first 5 characters? Nope. So consequently, what do we need to do again? We need to take care of it for us. Or we need to take care of it manually. Now, is that the way to do it? Nope. CHRIS and then the null terminating character? No, I want CHRIS, HELLO, and then the null terminating character. So, where was it going to go? 5 plus 5 is 10, right? Because you start at 0. 0 through 9 is Chris, hello, and then the 11th one at index 10 should be the null terminating character. There we go. So byte limited versions on both of these allow you to do substrings. Right? Only parts of the first part of the string. Right? What we're going to do on Wednesday, is we're going to adapt this. Let me go ahead and put this over here so that you have it in your notes, and for the lab if you need it. But otherwise, challenge for Wednesday: get a substring of a string. Right? That is part of a string starting in the middle. For example, going back to my name here, I want to isolate my middle name, Michael. How can I get just that part and put it into another string so that I have my middle name instead? So char middle name 50. I want to process this string so that I only have that part in it. All right? And we'll talk about how to do that on Wednesday. Any questions? Okay, good luck in your lab.